I started using SAS in 1977 while working as a research mathematician for the USDA Agricultural Research Service at Penn State. Actually, the grants from the USDA provided Dr. Goodnight with funding. They actually resulted in the development of the statistical analysis system. I think it was a little NIH money and a lot of USDA money that got them started. I have a bachelor's degree in math with a minor in physics from the University of Vermont and a master's in stat from Penn State. I want to talk a little bit about my life's journey to whatever I am now. I think it's a result of what I call the 4 C's. I've been thinking about this a little bit the last couple of days, and I think the key things in becoming experienced in anything is having curiosity, creativity, community, and caring. SAS has provided me with a foundation so I could kind of practice and do these traits. And what I want to do is I want to take you back to the 20-year period from 1950 to 1960, because I think this is a prelude to where I am now. I do remember in junior high school, maybe 10, 12, 13 years old, doing some odd things like throwing a stake into a pond and coming back a week later to see what kind of crazy creatures were attached to the stake. I also remember building a chem lab in my basement and ordering laboratory supplies like a Bunsen burner and flasks and sulfur and St. Peter. I was going to make some fireworks. I also was an avid rock collector, and I was very fortunate because there were 2 ladies who lived in my neighborhood who traveled the world collecting rocks and minerals. So I really had a very good rock collection, which I eventually donated to my high school. But I think it was in my sophomore year when I purchased my first slide rule. And I remember this as kind of a key point in becoming a mathematician. I remember going to the local bookstore and eyeballing the slide rules and kind of drooling over them. It was called Baker's Bookstore. And I remember looking at the mahogany and ivory Knuffel and Essler K&E slide rules, which I couldn't afford, but I noticed that there were some plastic ones that had all the functionality, the trigonometric functions and the arithmetic functions, and I decided to get that one. However, I do have the mahogany one now, which you can see here. I eventually bought it. At any rate, the slide rule kind of was my first introduction to mathematics. In my senior year, my curiosity and creativity seemed to bloom a little. My high school was one of the first back then to offer calculus to seniors. I would make up problems based on Newton's laws and try to solve them. For instance, I remember a problem of shooting a bullet horizontally over a plane in a vacuum and noting that it fell to the ground at the same time as a bullet dropped from that height. So it was kind of turned me on a little to more advanced mathematics and curiosity and kind of creativity. And then my 70s and 80s were my college days. I remember my first program was finding the roots of a quadratic equation. Punch cards and maybe 2 runs overnight. And then if you made a small mistake, you were there an extra hour, it seemed, just trying to get the operator to run your card deck, which was packaged in a rubber band. At the time in college, I also had a part-time job with the USDA, and they were using what are called Frieden mechanical, I don't know, adding, subtracting machines. Made a lot of noise with a big motor, but a little later, they picked up something called a Wang computer, which was, I think, one of the first desktops. It didn't have BASIC. It was before BASIC. It had some reverse stack type, very elementary, almost assembly-like language. But it did have a typewriter, a Selectric typewriter you hooked into it, and you could do some simple plots and some mathematics. Later in the 70s, I remember my first calculator, which was an HP 25, which also was programmable. And I did quite a bit with that, I remember back then. Then came SAS. Okay, it's the 70s, late 70s now, and here comes SAS. And I remember distinctly one of my stat friends showing me his program, and he had this funny thing. He had this percent sign, and then he had some text. He had another percent sign, and then he was executing this multiple times. And I said, gee, that's really neat, you know. And then he showed me his data step and the sort that he was doing using the mainframe sort, and he was cleaning his data. And I said, this is much better than BMDP or IMSL. And at that point, I switched. I decided I was going to learn SAS, and it was useful in my job. I became a SAS programmer basically by solving problems and getting very involved with the SAS community. I think that's where I grew the fastest, was solving problems and using SAS in my work. I worked in pharmaceutical, financial, and academic, and also big business in computers. I worked with a large computer manufacturer in what was called their Pinnacle group, which developed and designed future mainframes, and that's where I really learned about hardware and software and how they interact. And then that also helped me in SAS in writing efficient programs. About some things that people could focus on that would really improve their programming. You know, I think one of the things that can really help move people along is if they focus more on data steps instead of focusing on static reports. For instance, I'm more interested in getting a data set out of proc report or out of tabulate, and then using it to put out a second report, which is more flexible. You know, I think people focus too much on just the report and not the data step, and I think they often get painted into a corner where a manager will come to them and say, I want an across column to have a different format than other across columns, which you really can't do with proc report. Or they want n parentheses %, or they want some variation. Whereas if you use proc report to get the output, you could then easily manipulate it with another proc report to get any kind of flexible report you like. Also, I really feel programmers should think about augmenting the foundation of SAS processing with R, Perl, and Python. I've kind of developed some techniques which make it easy to interface SAS, R, Perl, and Python, where you can even pass macro variables or use the clipboard to move data and text back and forth between R and SAS. Also, I think one thing that I think could really help programmers too is if they consider what I call the classic SAS on a power workstation. I think this is a platform that is underutilized. The classic display manager system has the ability of executing almost anything on the command line. There's things called command macros, which are not used as much as they should be, I think, which enable you to even operate on text in the editor. You can map functions to your mouse. I have a 5-button mouse, and I have about 20 actions mapped to the mouse. You have function keys. You can have multiple monitors with a workstation. You can extract and operate on the text in the editor, which is very powerful. As far as procs, I think SQL, and especially SQL pass-through to various databases, even Excel, Oracle, Teradata, is something people should be thinking of more often than using. I think the explicit pass-through is much more powerful than the implicit pass-through. So SQL is one of my favorite procs. Another one of my favorite procs, which is very underutilized, is something called CORISP, which is corresponding proc CORISP. Now, proc CORISP is the only procedure that I know of in SAS that can transpose and summarize multiple or multi-dimensional crosstabs. And what it gives you is the crosstab, which would require a sort and a sort, transpose, and summarize 3 procs to do any other way. So I think people should be looking at this proc to produce a data set that they can then easily put out a pretty report with. I really think there's too much emphasis sometimes on pretty reports where users should be thinking about creating a data set that's close to the final product they want. Another thing that's very underutilized, I think, is what I call normalization. People get into the Excel type, I don't know, they think in terms of spreadsheets, when a structure that is long and skinny that can be easily pivoted or transposed is much more powerful, especially with SQL, than a fat data set. And designing these normalized data sets is key. I also want to talk a little bit about, I don't know if I should name them, but if you want to become a guru, I really think you have to get involved in the community. There's several lists out there. There's the SAS Forum, SAS-L, Stack Overflow SAS, and also Stack Overflow R, Python, and even Perl. And it's to your advantage to take advantage of these, to ask questions, to see what questions other people are asking. Also, something that has really helped me is over the past almost 50 years, I've kept almost every SAS program I've written, and I've shamelessly stolen many from the community sites, and I do have the acknowledgments with them, but there's some 20,000 programs in one of my folders, and I also have a file that has basically all my responses to various lists over the last, at least I would say 30 to 40 years. So it has, like, right now it has over 3,000 tips in it, and some of them are quite long and quite extensive, but if you do keep an archive and you do keep track of what you've done, I refer to these all the time. In fact, I'd say 50% of the problems that people post on lists have been solved, and many of them I have the solution for. The only downside, I think, is that SAS, I can look at some of the old tips and they don't apply anymore because SAS has actually supplied new functionality that takes care of those issues that people had in the past. I think also that you can't be afraid to express your opinion, and this is one thing I believe in, which goes counters to a lot of the lists. I know Stack Overflow, I cannot do a soapbox on Stack Overflow because it's an opinion. I think opinions are important as long as you wrap it in some kind of, I wrap my opinions in soapbox on and soapbox off, and I think these are key for people to understand the psychology of software. There's so much misinformation out there about software, and there's so much gobbledygook that someone has to express a contrary opinion. And sometimes I go too far the other way on purpose because the marketing is so bad in one direction that people need to be jarred and think about, well, there's an easy way to do this. We just do it this way. It may not help the bottom line of SAS or others, but it's the way to go. So I try to, and I didn't do that early on in my career, but now that I have the experience I do, I feel justified in writing these little soapbox vignettes or whatever you want to call them. But I think you need to be, like I said, curious, creative, and don't take, a lot of times I'll try purposely not to take the common solution. I like to go the path not taken. You should think about other ways of solving a problem. One thing I really like about the new SAS forum is there are some very novice users, some very non-programmers, and they ask questions that are really out of the box, that are just wild. And I really like to think about, why is it that, that we can't do this with SAS? Something like, why can't I easily determine that the face is a person, or that the round object is a basketball, or whatever? That's when I think, well, gee, there's these Python modules that are built for AI that do these, can recognize license plates or dissect video and stuff. It just kind of opens up other avenues and other ways of thinking, especially with AI. AI is becoming a very important software area. One thing I sometimes think of is the right amount of code to do a problem. I know this sounds kind of odd in some ways, but if you have the right combination of procs, you can sometimes solve a problem in a half a page where others are taking 3 or 4 pages and 10 or 15 procs. And also, I used to be very familiar with IML, and I've sort of switched to R. And there are things you have to think in the back of your mind, what is the best set of procedures, or what is the best algorithm to solve this problem? You shouldn't just think, well, I've got to use proc report, or I've got to use proc tabulate. You should think about, what is it that I'm trying to do, and how flexible can it be, and how can I keep it so that it's got the right amount of code that people can understand it and can maintain it. Those sorts of things. Multidimensionality and get it out into a rectangular form. I've also started to use proc report a lot more to transpose and summarize. The only problem is you do get underlined C variables, but they come out in alphabetical order, and you can do things like have a name and a value, like January, and then have some population, February, some population. You've got a categorical, and you've got a numeric, and you've got multiple combinations of pairs going across. Now, there aren't, only chorus and report can output a 2-dimensional rectangular data set of that form. And what's nice about report is you can do summarizations and sorting all in proc report. You don't need a proc sort. You don't need a transpose. So chorus, unfortunately, tabulate does not honor printed output. It doesn't honor what you're seeing on the screen is not what you're getting in the output data set from report or from tabulate. So I'm interested in these output data sets that a lot of these procs put out, because I don't want to be, I've been painted into a corner too often by a manager who says, I want it this way. And proc report with a cross, it's limited. I'm in the same format for each cell, each column. And because of Ian Whitlock, Quentin McKellen, Steve King, Soren, Aaliyah, both Arts, Art Carpenter, Art Tarbuck, Roland Rashbury, Peter Flom, Joe. I have a list of about 50 people I keep that I have contacted and kept in contact over the years that are responsible, I think, for what I know and what I can do. And I'm also starting to build a little list with R with some of the R programmers because unfortunately IML is not used as much as it should be used. But it wasn't part. It used to be part of BASE, and there was something called proc matrix years ago, and it was part of BASE. The minute I really got upset at SAS, I wrote to them, I did, don't take proc matrix out of BASE. Well, they took it out, and out comes R, and just I feel R is devastating proc IML. I mean, it's sad. I mean, I used to do a lot of IML programming, but I don't anymore. I can't keep up on R and IML. So those 6,000 R packages, I mean, you've got to also look at, some people try to roll their own in SAS, especially when they don't have time series and they don't have the ETS package. There are some excellent R packages for doing that kind of stuff. Perhaps that's not what you want to hear, but I mean, I think it's the real world. I always, too, try to keep what's best for the programmer in mind. If I'm writing something to a SAS list, I will put R in there if I think it's appropriate. And I think SAS has seen that. I know with this VIA, they're integrating more closely with Python and R. That's that new product. Unfortunately, it's purely cloud, and I feel the cloud is important, but I also feel a good, powerful workstation connected to a good server is really the way to go. I mean, it's just if you're a non-programmer, you know, the cloud and the servers out there are probably fine with their lockdown states and things like that. They're probably fine, but for a real programmer, it's nice to have local SAS.